Again, all of you warm welcome to my YouTube channel. Myself, Manish Godaji. I am currently pursuing the education in Venkateshwara College of Engineering. In this video, I will going to explain the mechanical concept, that is working principle of four-stroke petrol engine, how the four-stroke petrol engine works, and what principles. Let us. So it is worked on the principle of theoretical Otto cycle or the constant volume cycle, and it is also known as Otto cycle engine. It is invented by the Nicholas August Otto, and you can see here some of the pictures of four-stroke petrol engine, and here I pasted on GIF how it is worked. So let us move to the next topic. The four different strokes are: one is suction stroke, compression stroke, power stroke, and exhaust stroke. Okay, the first one is suction stroke. This stroke starts when the piston is at TDC and about to move downwards. During this cycle, inlet valve remains open and it is a outlet valve. Exhaust or the outlet or exhaust valve remains closed. During Due to the low pressure created by the downward moving the piston, the charge is drawn into the cylinder. At the end of this stroke, the inlet valve closed. Okay, then we can move to the next. Okay, the second one is compression stroke. During this stroke, the compression of fresh drawn charges takes place by return stroke from BDC to TDC of piston. During this, both inlet and exhaust valves are closed. Here the inlet and exhaust valves are closed. As the piston moves upwards, the petrol mixture in the cylinder is compressed automatically. The pressure and the temperature increases. The combustion of fuel takes place at constant value. The compression ratio in the petrol engines ranges from 7:1 to 11:1. And the third one is power stroke, and it is also known as expansion stroke or working stroke. At the beginning of the stroke, piston is in at TDC, and during the stroke, piston moves from TDC to BDC, and again it will move from BDC to TDC. And during this stroke, both inlet and exhaust valve remains closed. The combustion of fuel liberates gases, and these gases start expanding. Due to the expansion, the odd gases exert a large force on the piston, and as a result the piston is pushed from TDC to BDC, and the power impulse is transmitted down through the piston to the crankshaft through the connecting rod. A part of burn gases is released in the exhaust valve. Okay, the last one is exhaust stroke. At the beginning of the stroke, piston is in BDC, and during the stroke, the piston moves from BDC to TDC. Okay, BDC to TDC. Okay, during this stroke, the inlet valve is closed. The inlet valve is closed, and exit valve or the outlet valve is opened. Okay, as the piston moves upward, it forces the remaining burnt gases. Here the remaining burnt gases move out from the cylinder to the atmosphere. Okay. When the piston reaches to the TDC, here the piston reaches to the TDC, the exhaust valve closes. Here the outlet or exhaust valve closes. Okay. And this completes one cycle, and in the next cycle the piston is which is at the TDC, it moves to the BDC, and again the fresh charge is entered to the cylinder, and the process continues to the second cycle. Okay, this completes the four-stroke engine cycle. And the next slide, here we see, here in this slide I pasted one graphical representation and one table, right? It explains the clarity of the four-stroke petrol engine. You may see here one is pressure, y in the y-axis, in the x-axis volume. Here A and B in the volume section, it explains the section of air and petrol, and here in the And the next B and C, it is also in the volume in reverse. It explain the compression of mixture, and in the C and D it is a pressure as the constant volume combustion. Okay, and the D and D in the volume in the x-axis, it explains the expansion stroke. Okay, and E and B it is in the pressure as the result. It explains the exhaust valve opens, how the exhaust valve is opens. And B and A, and it is also in the volume, so it explains how the burnt gases is released to the atmosphere. And it is B and A is exhaust of combustion product. Okay, in the table let us see the strokes crank rotation. Okay, in the section it takes place 0 to 180. In the compression it takes place 180 to 360 degree. In the power or working, the rotation takes place in the 360 to 540 degree. In the exhaust it takes place 540 to 720. Okay, thank you for watching my video.